All right, example number 4 here. So again, just getting a little bit more complicated, lots of pieces floating around there. We're just going to group all the like things together. Notice what operation is going on between every single piece. It is all multiplication. Each one of those pieces is its own piece and can be moved around via that commutative property. So, just like we did before, we're going to group all the pieces together. This time, I'm going to start with doing all these constants or numbers first. So, 3 times 5 times 4. Well, 3 times 5 is 15, and 15 times 4 is 15 times 2 is 30, so 60. Boom. Next, I've got some a's. I've got an a to the 7th here and an a to the -2. Ooh, negative exponents. Negative exponents. Oh, geez. Don't know what happened there. So don't let those negative exponents freak you out. We're still going to combine that a to the 7th times a to the -2. So there's two different ways you can look at this. If you're looking at this via the rule, the shortcut rule, that tells us that we can add those exponents, when I add -7 and 2, that gets me a to the 5th. And why that happens is because, remember, those negative exponents, to make them positive, we need to move their placement. We need to change their placement. And right now, that a to the -2 is on the top of a fraction. So to make it positive, I need to move that to the bottom of the fraction. But the a to the 7th is not going to change because that one's positive. So that a to the 7th is going to stay on top, but that a to the -2 is going to go down to the bottom. And in our next lesson, when we get down to the division, you'll see why this is going to work out this way. But what actually ends up happening is we have 7 A's on the top. We have an A and an A and times an A times an A times an A times an A 7 times. 2 on the bottom. 2 are going to end up canceling out. So we'll talk more about that in the next video. Yay! Okay. And then, last but not least, taking a look at our b's. I've got a b to the 4th. Ooh, and a b to the 0. Maybe remind yourself that anything to the 0 power is not what you would think it would be. It's not 0 like you might be thinking. Anything to the 0 power is actually 1. So, x to the 0 power is equal to 1. B to the 0 power is equal to 1. Any variable that you have raised to the 0 power is going to be equal to 1. The variable goes away. The base is no longer there. It just cancels out and is just 1. That also makes sense because if we look at our rules, we have b to the 4th being multiplied by b to the 0. Our exponent rules tell us that we are allowed to add those exponents since they have the same base. So b to the 4th plus 0, 4 plus 0 is still just going to be b to the 4th, which also makes sense because b to the 0 turns into 1, which is just b to the 4th. Okay, so last but not least, to finish this off, I don't know why that's giving me such a hard time. There's probably a smudge on my screen. We're just going to put all those pieces back together. So we had that 60, a to the 5th power, and b to the 4th power. Final answer. In the next video, we'll take a look at dividing exponents.